the explorations of the fundamentals of the deep learning and generative AI. Understanding deep learning. Introduction. This presentation provides an overview of the deep learning, its significance in AI, and its application in generative technologies. Deep learning basis. What is deep learning? Deep learning is a subset of machine learning that utilize neural network with many layers, deep networks to model complex pattern in data. It enables computer to perform tasks such as image and speech recognitions, neural language processing, and even playing a games at superhuman levels. Neural network explained. Network consists of interconnected nodes organizations layers, input, hidden, and output layers, each neuron processing data and applies an activation function, transformation the input into an output. The learning processing involved adjusting the weight of the connecting between neuron to minimize the error in predictions, achieved through techniques such as back, propagations and gradient descent. Key concept and terminology. Key concepts in deep learning include overfitting, underfittings, hypothesis, and the batch size. Overfitting occurs when a model learns the training data too well, capture noise instead of the underlying patterns, leading to poor performance on unseen data. Understanding happens when a model is too simple to capture the complexity of the data. Epochs refer to the number of complex passes through the training datasets, while batch size is the number of training samples uses in one interactions of model training. Generative AI. Introductions to generative model. Generative model are a class of model in machine learning that generate new data science that reassembles a given training dataset. They learn the underlying structure of the training data, allowing them to produce new content, be in image, text, and audio. Popular types of generative model include variational au- autoencoders and generative adversarial network, each utilizing different mechanisms to achieve generative. Type of generative AI techniques. There are several techniques in generative AI, including adversarial network, which involve two neural network contexts with each other to create realistic output. Variational autoencoders, which focus on encode input in a similar latent space and then reconstructions it. And diffusion model, which gradually add noise to data and then learn to leverage the process to create a new data instance. Applications of generative AI. Generative AI has a vast application across multiple industries. In the art of entertainment space, it is used to create artwork, music, and even scripts. In marketing, it can generate custom context for target audience. In healthcare, generative model aid is in the developments of the new drug by simulating molecular structure. Furthermore, they play a key role in gaming, creating realistic environment and characters, and enhancing player engagement. Conclusions. Deep learning and generative AI represent a significant evolutions in artificial intelligence techniques. Understanding their fundamentals and applications not only provide insights into how these models work, but also open up new opportunities for innovation across various fields. Continued research and development in this area will likely yield even more powerful tools and applications in the near futures. That's all for today's sessions. If you have any questions, you can ask me. Thank you.